Okay, now in this lesson, we're actually going to take data and create basically a scatter plot in the graphing calculator, and then find the line of best fit or the curve of best fit that goes through it, and then use that line, that curve, to make predictions about the future. So in your notes, I have this particular slide and the following slide. And these two slides you will need to use in order to solve the following problems that I have set up for you. Okay? So we will refer back to these slides in just a moment. But let's get started with some actual problems. Now, these are the directions. This is how I'd like for you to work the following problems. So for each question, you will run the linear, the quadratic, and the exponential regressions. You will write, so part A, you will write down the correlation coefficient for each of those, and it will be 4 places after the decimal. Okay? Then which model, we'll look at the R values, and we will determine, based just on the correlation coefficient, which models, which is the best. Will it be the linear? Will it be the quadratic? Or will it be the exponential? We're going to make that decision based on each one of their R values. I'll talk about that in a little bit. Okay? Which model's best? And then you're going to write the equation of the best model from part A. So write the equation. And then we're going to answer questions about the data, regression, and predictions. We're also going to answer questions about how the context affects which model is best. So here we'll talk about how does the context affect the correct choice in the model. So we've got a few things to discuss here, and it's all going to kind of run together. So let's look at the first problem that I've set up. Let's suppose that you have a some sort of, I don't know, bike and jump, like bike jump competition. Okay, so there's people that are riding bikes, and the bikes weigh different amounts in pounds, and then as they ride the bike they'll make jumps, and so these jumps are in inches. Okay, so a bike that weighed 19 pounds apparently jumps 10.35 inches off the ground, whereas a bike that weighs 24 pounds would jump 9.6 inches off the ground. Kind of a weird example, but I'm just trying to get some data here and give you an example of how this all works together. So let's get started. What we're first going to do is take our calculator. Everybody have your calculator. Turn it on. Now, in those previous slides that I showed you, we have some tasks here. And this first task is something that you'll never have to do again. You'll do this once. And never again. Unless you reset your calculator. Or maybe you're borrowing someone else's calculator. What's up, Snow? How you doing?
Been a while.
It's been a while.
Exactly. listen. Yeah.
I mean, it's not thick,
It's
but
not
like it's
thick.
a lot more.
Okay, so you'll do this, and you'll never have to do it again unless the calculator's reset, or if maybe you're borrowing someone else's calculator, and their calculator is not set up to display the R value. What we're about to do, every time we do it, it'll give you an R value. And if it doesn't, then this is the step that you need to go back and follow. All right? So right now, I'll show you how to do that. Take your calculator. You're going to hit the second button, second, and then the 0 button is the catalog. So now you're going to select the down button and let it scroll all the way down until you get to the diagnostic on option. So we select diagnostic on by pressing enter, and then we press enter.
Diagnostic on.
And we press enter one more time. It'll say done, and that's it. That's all it's going to tell you. We're good. So now what we've done is we've set up our calculator so that it will give us the R value as we do these regressions. Okay. So next, our next step is to enter the data. So we're going to come back to this problem. Now, by the way, it gives you the directions right here in written format, although I'm going to tell you, so we're going to hop off of this screen here, and we're going to actually enter this data in. Now, how do you enter the data? You press stat. You want to stay with me on this, by the way. If you get behind or whatever, it's hard to catch up. So the moment you're not where I'm at, raise your hand and let me get you caught up. So you press stat, and then you select edit by pressing enter. Now, let me freeze you right there. Let me freeze you right there. You should see L1 and L2 here. You should see it. But not everybody necessarily sees it because somebody else has used that calculator before, and possibly they have deleted one of these lists. Let me show you, well, if you ever get on here and a list is missing, such as list 1, the way you would make that list reappear is to press stat, and then come down here to number 5, setup editor, hit enter, it'll say done, and then you go back to stat, edit, and then your L1 or whatever will reappear. Alright? So I'll probably create a video that goes over all of the little errors that you could run into as you're doing these problems. And there's several. So if you ever notice anything that's weird, just raise your hand and let me go ahead and solve that problem for you. So anyway, let's enter the data. 19, 19.5, and so forth. If you're watching the video, you can pause the video right now and enter the data in on your calculator, and then restart when you're ready. Okay, so I've taken a moment and I've entered in my data, but what am I noticing? What are you noticing that's a problem? They're not lined up here. I've made a mistake somewhere. And trust me, if you make a mistake as you enter your data, then everything else that you do will be wrong. There will be mistakes. Okay? So you have to make sure the data entry is accurate first and foremost. So in my case, how can I fix this? Well, I need to review my entries. 9.6, 9.7, 9.79, 9.8, 9.85, 10.1, 10.2, 10.25, 10.3, 10.35. That's correct. So maybe I missed something over here. Ah, did I? I forgot the 20.5 right here. So notice, I need a 20.5. I don't have to delete everything and restart this. I can just press second, and then this button right here, there's insert. The delete button right above it, it says insert. So I can press that, and inserted a 0, I'm going to type over top of that right now 20.5. Hit enter, and now my lists are complete and they're accurate. Okay, raise your hand if you need me to wait before I move on, because I'd happily do that. Okay, I'm going to move on now. So I've entered the data. Just go back and peek at the next step. The next step is study the models. What do I mean? I mean, you're going to follow these directions right here. You're going to press these buttons. And it's going to be a little bit different for those of you that are on TI-84s, but I'll explain it all here in just a moment. You're going to follow these steps, and you're going to repeat it for both the linear regression, the quadratic regression, and the exponential regression. So here we go. I'm going to press, at this point, I'm going to press stat.
We do the same thing for the 84?
Yeah, just follow along. Everybody on this TI-83s and TI-84s. So you press stat, arrow over to calc, and then you're going to arrow down to where it says number 4, lean reg. It's linear regression. So hit enter. Now freeze right there.
Yeah.
I said freeze right there, so there's going to be differences. Okay? So for a TI-83, you're going to press the following. You're going to press, so you got lean reg. Then I'll show you where these buttons are in just a moment, so just pay attention to what I'm saying. You'll press L1, comma, L2, comma, and then Y1. Like it's going to be printed out right here. Now, how do you get each of these things? I'm going to show you in just a moment. Well, I'll show you right now. L1 comes from pressing the second button and then the 1 button. The Y1 comes from pressing these buttons. You'll press the vars button. Then you'll arrow over to where it says Y vars. Then you'll select function. And then you'll select Y1. Okay? Now this is the way it should look on your TI-83 when you're ready to press enter. Now if you're on a TI-84, which I think most of you are at this point, the moment you pressed linear regression, you got a brand new screen, a new menu sort of thing. And it gave you some options. It gives you X list, Y list, and so right here under X list, you need to select L1. That's the same L1 that I have right here. You'll select the Y list L2 by pressing the second button and then the number 2 button. And then you'll come down, there's something else there, I forget, what does it say? Oh yeah, it says like frequency list. Skip that, and then where it says store regression equation, right here is where you're going to press Y1, and this is the same Y1 that I had typed right there. Okay, so to get these, see notes, over there.
You can hear it quick. Yeah, I'm pretty sure if you just click.
Okay, so what we have here are these are the steps for the TI-83, and these are the steps for the TI-84. I want to emphasize finding the L1 and the L2. You do that by pressing second and then the 1 button or the 2 button. And getting this Y1 right here, you know, if you've been with other teachers, if you've heard from other teachers, there's ways of doing this without pressing L1, comma L2, comma Y1. It's possible. You can do it totally. But there's a benefit to pressing it, and that's why I'm having you do that right now. Here in the next couple steps, we're going to use this Y1. It will be used. Okay, so that said, we're going to just make sure that you get these steps. How do you find the Y1? Press the VARS button, which is right here, just diagonally below the arrows. If I press it, then you get some menu options. You want to select Y-VARS, then function, and then Y1. Okay? Okay, so now I'm on the TI-83, and I'm going to go ahead and follow the rest of these directions here. So I pressed linear regression. Now I need to press second, and then the 1 button to get L1. Now, ladies and gentlemen, if you're on the TI-83, these commas are important. You have to put the commas there. Where's the comma? It's above the 7. So I'm going to press the comma, and then I press second and the 2 button to get L2. So it says L1, comma, L2. I'm going to press the comma again, and then now I want that Y1, which I've explained to you right here. So I'm going to press VARS, and then I want to arrow over to where it says Y-VARS, function, hit enter, and Y1, I'll press enter. So this is what it looks like if you're on the TI-83. If you're on the TI-84, it literally looks like the X list L1, Y list L2, stored regression equation, Y1, it's all written there. And now, so where it says on the TI-84, if it says frequency list, you can skip that. And then you'll arrow down here below where it says calculate. If you're on the TI-83 right now, you can press enter. If you select calculate on your TI-84 and press enter, it will all do the exact same thing right here, right now. So let's do that. Okay, so we have linear regression, and we're going to go ahead and write down this information. The information that I'm needing, if you go back to the directions that I gave you over here. Now I gave you these directions on one slide so that I wouldn't have to repeat them on every other slide. Part A, I want you to run the linear, quadratic, and exponential regressions, then I want you to write down the correlation coefficients to 4 decimal places. So let's do that right now. Okay, so the R value for the linear regression is the following. Negative 0.99115, so that would actually round to negative 0.991 what? 2. Okay? Now, I ran the linear regression, and I got the linear R value. Now I want to do the exact same thing with the quadratic regression. So I can press stat, arrow over to calc. Select number 5, which is the quadratic regression, and follow those same steps. Following the exact same steps: stat, calc, quadratic regression, and now you do second. Well, if you're on the TI-83, you do L1, comma, L2, comma, bars, y bars, function, y1. Okay, is there anybody in my class here that's got a question?
Yeah, I got A, B, C, R2 when I did the quadratic.
A, B, C, R2. Let me look at it.
I don't got two.
Yeah, I haven't done it yet, so that's good.
Oh, well,
Okay, I haven't pressed enter yet. I just want to make sure that you're here. You guys good? Ready to move on? Press enter. Okay, so it gives me, notice this equation that it gives me here. This is not like a line, y equals ax plus b, mx plus b. But now this is y equals ax squared plus bx plus c. This is a quadratic equation. All right? And it tells me what the a, b, and the c values are. So if I wanted to know what the equation of the curve that goes through the data here, the bike weight, the jump height, this curve goes right through the middle of all those data points on the scatter plot. All right, if we were to graph it. Now, so those are the a value, a, b, and c values. Now the r squared. Here's the thing. Technically, what we're doing is not. It's not the most appropriate or mathematically correct way of doing this, but what I'm really trying to do is generate discussion of the correlation coefficient and compare models. I'm trying to compare lines, quadratics, and exponentials. And so right now, just to have a little bit of a discussion, it gives us an r squared value, which is 0.9825. If you will, okay, we'll talk about C in a second. 9825. I don't want to stop here on the r squared. I want to go 2 more decimal places. Let's go to 39. I'm taking that a little bit further so that now I can take the square root. I can take the square root and get an r value. So these are not exactly the same r values as what the linear r value is, but just roll with me, okay? Just go with it. So now what I'm going to do is I'm going to press second, the square root button, which is right here, square root, and I'm going to press in 0.982539. The r squared, I'm going to take the square root of it. I press enter. It gives me 0.9912. So what I'm going to do is say that r, technically it's big R, but I'm going to say r is equal to 0.9912. All right? So there's an r value for the lines. Here's a slightly different type of r value for quadratic, for the quadratic model. And now let's look at the exponential model. So we're going to repeat the same steps. Stat, arrow over to calc, come down to, I believe it's number 9. Let's check. Nope. It's the 10th option, which is actually option 0. Exponential regression. L1, L2, Y1, okay? Press that. So on your TI-83, your calculator matches mine. On your TI-84, you got the different screen, but you still enter it in the same way as you did for the lines. And now you press enter. And you get these results. Notice it gives you an R value, which is negative 0.9910. Okay. Does anybody have questions for me to this point? Okay. By the way, I know that this is tedious and time consuming, but after you do this 3, 4, 5 times, it just goes real quick. You don't even have to think about it. And that's what our goal is. Okay? So let's go ahead and answer the rest of these questions. For part B, it says, which model was best according to the correlation coefficients found in part A? Linear, quadratic, or exponential? So let's look at that. According to these correlation coefficients, which is the best? I'm hearing people say quadratic.
Well,
Why is quadratic better than linear?
because if you graph it, the quadratic graph is better than
If you graph it, the quadratic graph matches it better? Okay, well, according to the R values, these two are equivalent. Now, this is a negative R value. That's a positive. It's not the same value technically, but we're going to pretend that it is. These two values are the same. It doesn't matter whether one's negative or one's positive. Maybe the quadratic is a better option, but here's what I do. If there's ever a situation where the R values for any of these are the same or they're equivalent, then I'm going to pick the simpler equation. Okay, you're gonna choose a line over a quadratic because it's kind of less complicated. Okay, so let's select linear for now. So we're gonna actually write in linear right here. That's the winner. And now let's look at what does question C ask us. Oops. What does question C ask us? It says to write the equation of the best model. So what are we going to have to do right now? We have to go back and do all that entire process for the linear model. Okay? So let's go back here and press stat. Calc. The fourth option is linear regression. You can hit second, L1, L2, and Y1. Okay, so here's the equation. This is written in slope-intercept form. Y equals mx plus b, except it says ax plus b. You're going to write y equals. Now the directions, if you go back to the directions on one of those previous slides, it says that you're going to write your equations. Each of the coefficients will be 2 decimal places. So the R values up here, yes, I want 4 decimal places, and I need 4 decimal places on those. But for this, for the equation, I want 2 decimal places. So this is going to say y equals negative 0.16 x plus what? Plus 13.35. Okay, there's your equation. Now, would your model, let me see here. Okay, so the next step here is to start answering questions about the problem itself. All right? So, would this model, so what we have here is some data that looks like this if we graph it. It looks something like this. Okay? Here we have the bike weight. Here we have the height of the jump. And as the bike gets heavier, what do you notice about the jump? As the bike gets heavier, does the bike jump as high? No, it's heavier. Okay? So we've chosen the linear regression, and it's going to kind of come through the middle of this. So here's the question. This is important. This is kind of what we've been leading up to working on. It's one thing for you to be able to press a bunch of buttons in your calculator, but it's something completely different for you to be able to use that information, use that technical skill in order to make some sort of value judgment. Okay? Would your model, this thing right here, be more accurate in predicting the jump height for a bike that weighs 16 pounds or 30 pounds? Why do you say 16? I'm going to say 16 pounds as well, because, and it says, how do you know? You're going to say, since 16 pounds is closer to the given data. Right? 30 is what, 6 units away from the last data value. Right? So that's plus 6. And this going to 16 would be plus 3. The value 16 pounds is closer to the actual data that we collected. Does that make sense? Hard to see this right here. Any questions? Okay, now before we go on, I just want to give you a little taste test of what happened visually in the calculator. This is not necessary for you to be able to answer the questions that I've shown you. However, in the future, this little skill that I'm about to show you will come in handy. Do the following with me. Make sure your calculator's turned on. I want you to press graph. Just by pressing graph right now, I don't see any of this information. I don't see the scatter plot. I don't see the line. But I can do a couple things in order to see it. First of all, press second, and then the Y equals button. It gives us the stat plot menu. Right here, number 1 it tells you how you can turn plot 1 on. You're just going to select plot 1, enter, and you're going to select enter by you're going to select on by pressing enter. The next thing that comes up is the type. The type is the scatter plot or a line plot or bar graph. Lots of different options here.
Would you press after second?
Oh yes, second, and then the Y equals button. It takes us to the stat plot menu. So here, the scatter plot type, X list is L1. The mark, the Y list is L2. The mark, I like this first one here because it shows up better on your graph. Okay, so now we've turned the scatter plot on, but notice if I hit graph right now, it still doesn't show up. Why is that? It's because we're looking in the wrong place for it. Right here, we're looking from -10 to +10, -10 to +10 on the X and the Y axes, but our values are somewhere else. And thankfully, your calculator can lead us to the correct spot. If we press zoom, everybody press zoom with me. And if you arrow down to, let's see, zoom number 9, zoom stat. Press enter. Now all of a sudden we see the data.
Oh, I got it.
And the line comes up. Why did the line come up? The line came up because if you press Y equals right now, notice what it says right here. It's got our equation. Y1, by the way, Y1 equals -0.156x plus 13.348. Okay? We good on this? That was bonus. Now I want to show you one last thing and then we'll pack up for the day. We selected the model. Okay, notice we followed these directions. We displayed R. We got that. We entered the data. We studied our models: linear, quadratic, and exponential. Just look right here while I summarize everything. Okay. We studied our models: the linear, the quadratic, and the exponential models. 3 different models to represent the same data. We selected the best one based on the R value. We selected the model using the R value. Okay? We wrote the best fit equation to 2 decimal places. Okay, so all that information is printed there in your notes. Now, the next step is this is what we're leading up to. Nobody in their right mind ever takes data and does a regression equation just for the fun of it. The purpose of all this is what we're leading to right here, to be able to answer questions, make predictions. So you have 2 different styles of questions that could be asked. You could be given an X value and asked to find Y, or given a Y value and find X. And here are the directions for each of those. In our current problem, here's what I want you to do right now. We were talking about bike weights, which was X. Jump heights, which was Y. I want you to predict the height a bike would jump if it weighed 16 pounds. If it weighed 16 pounds. So how do you do that? Nope. You could. That's one option, but I want you to use this method right here. That actually is one method, but it's not the best method. So do this right now. In your calculator, from your home screen, you can hit second quit to get back to your home screen. You can even press clear. It doesn't matter. at this point, I need you to press VARS, which was right here, VARS, arrow over to where it says YVARS, select it, function Y1. Now, in parentheses, you're going to enter the X value. What was the bike weight that we were talking about? 16 pounds. So close the parentheses. So I follow these directions. I entered the X value, close the parentheses. Now I hit enter. Now, how high would we expect a bike that weighs 16 pounds to jump? 10.85 inches. Okay? So we can just make a note of that right here. 10.85 inches. That was a bonus question. Nowhere did I actually ask you to find that actual bike height. Alright, so ladies and gentlemen, thank you for watching this video. I'm going to have a couple more videos, more examples to do right after this.